Hey guys, Ryan from Slow Your Roll here. Today I'm going to be doing another video on an electronics upgrade to the Airstream Basecamp 20X. You may have recalled from previous videos that I did an upgrade to the solar charge controller, and I also installed an inverter. The original solar controller that comes with the Airstream solar package is non-Bluetooth enabled, but it is hardwired to a Victron solar MPPT monitor. Now, the information that's going to provide to you is what the panels are drawing in and what energy you're using from the solar. When I exchange that charge controller for one that's Bluetooth enabled, it's the Victron 100-30 solar controller. That gives me all the information I need right to an app on my phone. So I no longer need that physical display in the Basecamp. Old Victron MPPT solar monitor, I'm going to install this Victron BMV 712 battery monitor. What this is going to do is this is going to give me more information on my battery life. It's going to tell me how many amp hours I have, how many amp hours time I have remaining on the batteries. It's also going to give me the temperature in the battery bank, which is extremely important when you're dealing with lithium batteries. They don't like to go too high in temperature, and they don't like to go too low below freezing. So in this video, what we'll do is we'll do an unboxing. I'll show you what comes with the BMV 712. We'll take it inside the Basecamp. I'll show you how easy it is to install it. And then we'll go over some of the functionality of the Victron smart app that you can get on any smartphone. All right, inside the box. First thing is you're going to pull out your technical manual. Inside that manual is a quick install guide, which is really the only thing you're going to need to install this system. You've got RJ12 cable, which is your communication between the shunt and the monitor. This one comes with the temperature monitor. Two power cables, so one per battery. The shunt with all your connections, and the two battery studs here. The monitor head unit, and it also comes with this trim piece, depending on where you're going to mount it. The first thing you're going to want to do is mentally map out how you're going to set up the solar controller and where the shunt's going to go. So some of the things you have to keep in consideration when mounting this is all the negative load, so all the typically black wires are going to go to one side of the shunt, and then you're going to wire the battery negative cable directly to the other side of the shunt. So when you have the finished product, there'll be one negative wire from the battery to the shunt. Every other negative load coming off the shunt will be going to your negative bus bar, or in my case, I installed an inverter. So that's the line you see going out here. That runs outside to the inverter that I have installed on the other side, running into here on this side of the battery. So that's going to be removed, and that's going to be placed on the shunt, as well as this wire right here, which is going to my negative bus bar. And then all my other negative runs are going from that bus bar to whatever component is in the Basecamp. So after looking in my battery bank, I've established that this negative wire to the bus bar is my limiting factor. All right, it's only so big. Now I can easily install a longer wire. I don't have one, so what I'm going to do is you can see the Victron MPPT solar control that I installed there. Let's see if it comes into focus. Okay, if not, there's a little space right here that I think that shunt will fit perfectly. So what I'm going to do is I'm going to place that shunt inside against the metal trim there. See if you can see that. All right. And then I've got enough room to run my RJ12 cable and my power connections to the shunt. And I'll give you a better picture of that when I actually install it, since my hand's in the way right now. So for the sake of time, I disconnected the requisite wires. So this is the negative lead from that was on the battery that goes back to the negative bus bar under here. And then I also disconnected the negative lead going back to the inverter. You'll see I also mounted the shunt right here, which was probably the hardest part. Getting a drill in there and getting the screws in was very difficult, but we prevailed. One thing I want to point out about the shunt is these are 3/8 inch lugs. So if you don't have a 3/8 inch connector on your battery cable, you're going to have to change that out. Alternatively, you can take a 3/8 inch drill bit and increase the hole size. So next, what I'm going to do is I'm going to connect the battery cables back to this and then set up the wiring for the shunt. Won't be able to do that. Well, maybe I can. Let's see if I can set this up. What you're going to need for this step to connect the negative terminal of the battery to the negative terminal of the shunt is another negative battery wire. I just so happen to have a 5/16 inch connector and a 3/8 inch connector on this battery cable. So I'll take the 5/16 edge that fits the battery. Okay, so I'm just going to get it on there tight enough so that if I need to maneuver it around, I can. So on the shunt, you're going to see that it's clearly marked battery only and then load. So battery only in my configuration is on the top. So in the directions, it specifically states to connect the negative terminal of the battery to the shunt first thing before you do the other side. And then you'll cinch it down with an 11/16 socket. Next thing we're going to do is we're going to connect all the negative outputs to the negative output on the shunt, on the load side, which is the bottom in my configuration. Now you'll see I'm leaving the negative lead that goes back to the inverter off. I'm doing that on purpose. One, I don't need the inverter this weekend. Two, this is a 5/16 inch connector, so I'm going to have to get another 3/8 inch compatible negative wire here. All right, so right now I've got those, again, just tight enough so that they're not loose, but not so tight that I can maneuver the wires around if I need to. All right, so the next thing you're going to do before you power it up is you're going to connect one end of your RJ12 cable to the head unit, and then the other end of that to the shunt. And you're going to want to make sure you have enough slack on the RJ12 cable to run it to your final mounting destination for this. So again, this is just the way I do it. I like to connect everything here before I mount anything just to make sure it all works. In the directions, it has you find a location to mount this first and then run the RJ12 cable back to where you're going to be installing the shunt. Because I've got a few extra steps to do, I just want to show you the way I do it this way to make sure everything's working before we actually start drilling giant holes. So now that the negative lead coming off of the battery is going to the battery only terminal of the shunt, and I've got the load on the other end of the shunt, I'm going to disconnect the positive here. Let's get out of the way so we don't bridge a connection here. All right, so sorry that my hands are in the way. So basically I took off the other end of this nut here and I connected what in my package has the temperature sensor, and what this does is this also doubles as the power source. So again, if you rewind back in the video, it comes with 3 of these similar cables. They provide 2 in case you have 2 batteries, or in this event, the temperature monitor, which doubles as the temperature monitor and the power supply for the unit. So this for the shunt. So this connects to the positive side of the battery. So we're going to get that cinched up. Okay, so now that that's tight, you got your 2 leads here. If you look at the shunt, you're going to see these 2 orange clips and then 2 holes below those in the green section. So you're basically going to depress those 2 orange buttons and slide the leads in for the temperature monitor. We're going to take our power supply and we're going to connect that to the shunt. We've got power to the head unit. So now we're going to go through our setup process. So as you can see, here's the head unit right here. I've got the Victron app open on my iPhone, and then I've got the instruction manual with some notes that I took. So you can program the smart charger either way. You can either toggle through the 4 buttons here, or you can do it right from your app. I find it easier to do it from the app. Now, every time you install a new Victron product, it's going to ask you to update the firmware. So that's what that's doing right now. While I'm waiting for that to update, and again, don't leave the app or accept a phone call. Keep it next to the battery monitor. Let it update to 100% before you do anything else. What I do is, since I can't use my phone, I go onto the Victron website, and then I basically search what are the specific settings for a lithium ion battery. So depending on what kind of battery you have, whether it's a lead acid, AGM, or lithium, there's going to be certain settings that you need to put in to optimize the battery monitor and your battery discharge. Once you've got your firmware update, click on the settings in the upper right hand corner. Then you're going to click battery. First thing you're going to see is battery capacity. I have two 100 amp hour batteries, so 200 amp hours is correct. For the charge voltage, you're going to go to 14.4. Click OK. Current, you're going to keep it at 4%. Charge detection time, keep it at 3 minutes. For your Pukert exponent, you're going to change it to 1.05. Your charge efficiency factor, 99%. Your current threshold, keep it at 0.10 amps. And then the time to go averaging period, keep it at 3 minutes. The second step when setting up your Victron battery monitor is to go back into that settings, click on the relay, and then make sure the following parameters are input. On your relay mode, you're going to keep that at default. The invert relay you're going to keep off. Minimum close time and relay off delay are going to stay at 0. When you go to your low state of charge relay, you're going to set that to 5% on the set value and 10% on the clear value. On your low voltage relay, the set value will be at 11 volts. The clear value will be at 12.5 volts. The high voltage relay, set value 14.8 volts, clear value at 14.4 volts. Keep your low and high star voltage disabled. So what I did was I disconnected the shore power. I ran some lights and the fan and all that stuff just to kind of draw some of the power. So again, the biggest benefit to this system is it's going to give you your overall state of charge, which at right now is 100%. I've been connected to shore power for the last day, just took it off. The solar is working up top, but right now my batteries are sitting at about 13.5 volts, which is a little lower for lithium. Typically you're going to see them in the high 13s, low 14s, 14.1, 14.4. Currently, with what I've got going on in the rig, which really right now is only my refrigerator running, everything is off, I'm pulling 0.30 amps and I'm drawing -4 watts. So far in the last, I'd say 30 minutes, maybe less, I've consumed 0.8 amp hours. And then time remaining, currently, if I were to do nothing else, I could keep this going for 10 days. So let's get out of this screen and let's go to the Smart Solar MPPT charger. So this is going to tell me what my solar is doing. So again, like I said, I turned some stuff on to draw some power. And what you need to do is you need to take that out of a float charge because the solar is going to work to a certain percentage. Once it gets to a certain percent full, it's going to throttle down what it's bringing in. So right now it's only bringing in 55 watts, and that's just to basically top off the batteries because I'm not using that much. As you can see, I'm drawing 3.4 amps. The voltage is at about 16.9%. It's 3 in the afternoon, so the sun is not at an ideal angle. Voltage, I'm at about 13.52, which corresponds to the previous screen, and the current is 3.9 amps. The battery is currently in a float stage. All right, so let's go back to the monitor real quick and just pay attention to the current and power. So what I'm doing now is I'm turning on lights. You can see that that is going up. I'm going to turn my fan on. So the fan just made it jump from 2.9 to 3.4. And you saw that spike above 4 for the fan to turn on. All right. Let's see what happens when I turn on my hot water heater. All right, you saw that jump up to about 4.7. We're up at 60 watts now. And you can see the time remaining diminishing quickly. And it's going to take a little while to figure out, to calculate what that is, but eventually you're going to see that time remaining become steady state. All right, so let's shut some stuff off so I don't fill my gray tank up. All right, you can see that the draw has gone down. The time remaining is getting a little bit better. It's getting a little bit more steady, rather. 2 days, 14 hours. All right, so it's kind of steadied off right there. So it's about 2 days, 11 hours. So if I were to run the fridge, keep all my lights on, and keep the fan running, I'd have 2 days worth of battery left. Again, solar coming in is going to change that a little bit. But again, that's the benefit of having this in an integrated app. This is the current location of the old Victron MPPT monitor. The idea was to take this off, which you can access it by going into the top cabinet here. And then you remove this black piece. If you can see it, there's 2 screws up top, and then there's a screw down here at the bottom. Take that off and it exposes the wiring. Upon further investigation, if you go into your driver's side bench, where all the utilities are, you'll see down here that all the wiring, is all taped together. So it's not individual strands, and you can't get it through past the lavatory and then snaked into the battery compartment. So that's going to be an issue. What I'm going to do is, since it's Bluetooth and it's not vital at this moment, I'm just going to coil this wire up. I'm going to zip tie this inside the battery compartment so that it's protected. I can still monitor it using the Bluetooth function, but what I may do is take a hole saw and then just mount it right in here. The other option is I can contact the Airstream dealership and see if they have an easier way to pipe this thing through. But other than that, I'm kind of at a loss. If you have done this and you figured it out, please let me know in the comments below. But I hope you enjoyed the installation of the battery monitor. Like I said, it's really simple. Anybody can do it. Just be careful when you're working with batteries, and you should have an easy enough time. But again, this thing's going to be awesome for when we're off grid and boondocking, to just make sure that we've got enough life left in our batteries. Hey, thanks again. If you have any questions, please leave them in the comments. Till next time.